Hi class. So in this video lesson, we will state the characteristics of a function and represent continuous domains or ranges as inequalities. So we've already talked about continuous and discrete variables, and we talked about domains and ranges, but I want to refresh our memory on what those terms mean. So if we look here at the vocabulary, the domain and range. So what is that? Well, first, the values of the independent variable are called the domain of the relationship, and the values of the dependent variable, okay, dependent being our y, are called the range of the relationship. So the domain refers to our x values, and the range refers to our y values. We've also talked about discrete variables as things that can be counted and not separated into parts, and continuous as variables that can be measured, such as time, distance, weight, height. Okay, so our essential question for this lesson is, how can multiple representations of functions, being graphs, tables, mapping, other things we're going to be looking at later, how can they be used to reason and make sense of relationships and model change? So in our first question here, we have a ball that is thrown into the air. And if I look at my graph here, I have my time on my as t on the x-axis, and I have the height of the ball in feet on my y-axis. And you might notice here that instead of y, I have h of t, because they are basically the same thing. So this is my y-axis and t represents my x-axis. So I'm going to start first by looking at what are the independent and dependent variables for this situation. Well, based on what we just talked about, we know that the x values are the independent. X values represent the independent variable. So what's on my x-axis? Well, I have time. So I'm going to pull that over. My independent variable in this situation is represented by time. So what is my dependent? Well, my dependent is my h of t, or my y values. So all these are my y values. And that is the height of the ball, or the height of the ball in measurement as is measured in feet. So I'm going to pull that over. So now I have the dependent variable is the height. So again, remember, you can pause this at any time, and I encourage you to take notes, because I will probably move through this a little quickly. All right, so now I can go and use this information, my independent variable and my dependent variable, to write a function statement. Because if we remember, is a function of is just another way to say is dependent on. So what depends on what in this situation? Well, I know that my time is my independent, right? So what depends on time? The height of the ball. So I can just simply move height down, or I can move is a function of down here, and height is a function of time. The height of the ball is a function of the amount of time it's spent in the air. Okay, and just to refresh us on that, how we figure that out, we know our independent variable goes first, our dependent variable comes first, and we have is a function of in between, or which is the same as saying dependent on. Okay. All right. So now, just looking at the graph, we can determine if this is a discrete, if our variables are discrete or continuous. So I notice that there are no breaks in this graph, right? I also notice that we're measuring in time, or we're using time as our measurement. So this is a continuous function, because all of these points, if I were to say, okay, what is one, let's say 1.5, that would be included in this graph. 1 point 1 in 2500ths would be included in this graph. So this is a representation of a continuous function, or continuous variables are used. Okay, so now this is where this is new. This is going to be new information. So in our last unit, we talked about inequalities. So if we remember some of the ways we represented inequalities, and I'll just move this, well, I think I sort of locked it, so I'm going to write it like this. We had less than or equal to, less than, greater than or equal to, and greater than. Right? So less than or equal to, less than, greater than or equal to, greater than. So if I wanted to represent my domain, and I'm going to put that in red here, all these values, no, I thought I said red. Okay, here we go. All these values from 0 to 6 are included in my domain, are included in my x value, or x values that are included in the domain of this graph. Right? It doesn't go from 0 to 10, it stops at 6. It doesn't go from 6 to a negative number, it starts at 0. And so let me just move that down so it's a little clearer. So now, how do we do that? How do we write that as an inequality? Well, I know that 0 is the smaller number. X, which is all these, or in this case t, are all these values included from 0 to 6. So it's no smaller than 0. So it's greater than and equal to 0, right? And it's equal to 6, but not greater than 6. So it's less than and equal to 6. So if I were to make that as an inequality, and I'll just do it here, I would just have a line that looks something like this. So now I'm going to do the same thing with my range. I'm going to go from the highest point to the lowest point. And here again, my lowest point is 0. 0 is less than or equal to, because there's no value less than 0. And in this case, we're referring to h of t as our y values. And the highest it can go is 60. It doesn't go any higher than 60. So again, it is less than or equal to 60. Okay, so now this last question asks, in this relationship, can a domain value have more than one range value paired with it? Why or why not? Well, we have to remember, what is a characteristic of a function? They're basically saying, is this a function, yes or no? Well, I'm going to pull out our something that's going to help us remember. Well, let's see. So I have it right here from our previous class. We talked about what is a characteristic of a function. So a relationship, for a relationship to be a function, the x values, okay, or our domain here, can have only one y value, or our range. So in order for us to check that out, let's use our vertical line test. I'm going to take my stick here on my line, and I'm going to see at any point, does this cross my line more than once, the graph more than once? Does my x have more than one y value? Nope. Every x has only one y value. So yes, this is indeed a function. So no. Can a domain value have more than one range? And I'll just type that to make it easier. No, because this is a function and only one y value or range for each domain. and there is only one range for each domain. All right, so this was our first one of these. We'll be looking at another one in class. I hope this is helpful. If you do have questions, definitely let me know. Okay, take care. Bye.